Hi everybody, welcome back to this section 2.2 video. In this video, we're going to look at a couple examples of separation differential equations. Let's look at example one. We have dy over dx equals cosine of 2x. Okay, so how would we solve this using the separation method? So here I'm going to say use separation method. Okay, and so I want to get all my y terms on one side and all x terms on the other. Okay, I'm trying to separate. So one way I would do that, let me just rewrite this differential equation, give us a little more space. Okay, I want to get all my x terms on one side, all my y terms on one side. So I'm going to multiply both sides by dx. And so what I'm left with is dy equals cosine of 2x dx. And now the goal is to integrate. So all my y terms are on one side, all my x terms are on one side. So I'm going to integrate both sides. So let's integrate both sides. The integral of dy is just going to be y. And then the integral of cosine of 2x, that's a bit of a mental u-sub. So that would be 1/2 sine of 2x plus c. Okay, mental u-sub. How does that work out? So let's go off to the side and double check that mental u-sub. Okay, so say, I want to integrate cosine of 2x dx. Well, I like to think of it as a mental u-sub because we can do it rather quickly in our head. But here I want to show you guys the actual way we do it. So u would be 2x, du would be 2 dx. And we'd isolate the dx, move the 2 over to both sides. And so my u substitution would be cosine of u du over 2. And if I integrate this, it would be, or let me move the 1/2 to clean it up. Cosine of u du, it would be 1/2 sine of u plus c. And so we would plug in back our u, 2x plus c. So that's what I like to call a mental u-sub. It's just when we integrate, it'll just be whatever's inside of that sine, excuse me, whatever inside of that cosine, it will just be 1 over that constant. Okay, so that's a mental u-sub, but you can do it in your head or you can do the work off to the side, whichever works for you, okay? Okay, so let's go ahead and try out example 2 now. So for example 2, we have dy over dx equals y over 1 plus x. And so we want to integrate this. So this is actually separable. I know we talk about a product of uh, x and y functions, but this is being divided, so it is similar in a sense. So what we would do, let me just rewrite this. And so what I would do is isolate the dx. So I'm going to multiply dx to both sides. And so I would have dy equals y over 1 plus x times dx. And then what I would do now is divide y to both sides to get it to the left-hand side. So, uh, we could do like times 1 over y if that helps. So my y's cancel out, and now I have 1 over y dy equals 1 over 1 plus x dx. Okay, so now all my y terms are on one side, all my x terms are on the other. Now I'm in position to integrate. So integrate both sides. And so recall from your calculus 2 that the integral of something like 1 over u du is natural log of u plus c. Okay, so the integral of 1 over y dy would be natural log of y, and the integral of 1 over x, 1 over 1 plus x would be natural log of 1 plus x plus c. Okay, so we want to solve for y now. So what we're going to do to reverse that natural log is raise e to both sides. Okay, so when we raise e to both sides, we get rid of the natural log. And so what I'm left with is y equals e to the excuse me, what I get is absolute value of 1 plus x. Sorry about that, quick little typo. Um, Okay, so on the left-hand side, e to the natural log of y, that e and natural log cancels out. But here we have e raised to this entire natural log of absolute value of 1 plus x plus c. So before we start canceling out, let's just separate out these powers. So e to the natural log, absolute value of 1 plus x, and we can separate this out to be times e to the c. Okay, properties of exponents. Okay, so now what we can do is cancel out this e to the natural log. And so gonna bring this up over here. And so what I have is y equals absolute value of 1 plus x times e to the c. Okay, and so we have an absolute value here. So if you could recall some absolute value properties, such as that an absolute value function is really like a piecewise function. Okay, and we could determine some properties of this. So it would just be positive 1 plus x if my x is greater than or equal to negative 1. So if x is greater than or equal to negative 1, I get a positive 1 plus x. And I will get a negative 1 plus x if x is less than negative 1. Okay, so what are we doing this all for? So the idea is that we can understand some properties of this absolute value. And so what I would have is going to rewrite it a bit, but essentially plus or minus e to the c, absolute value of 1 plus x, excuse me, not absolute value. And then e to the c, e raised to some constant is just some constant as well. that plus or minus e to the c is just some d for constant. So our final answer, we could just write d times 1 plus x. Okay, so that is two examples of separ separable differential equations. One was a bit easier, one was a little more involved with getting to that final solution, but the idea is still the same, separating them, integrating both sides, and get to an explicit solution somehow. Okay, so that's it for this video. We'll check out some initial value problems in the next one, but take care. I'll see you in the next video. Okay.